Наступний спікер доктор Vasylyuk з Інституту органічної хімії імені Вернадського. Good evening. I'd like to present to you the results of a work which is still ongoing, since there is financing available. And we hope that we will not leave this work behind and will still find financial support in the course of this meeting, or somehow we don't leave hope. We're working on inorganic sorbents and membranes. Commercially feasible are products that are cheap on one hand or very expensive on the other hand. And the materials that have certain properties. We cannot orient our products on very expensive materials. We will be able to produce some materials which is going to lay on the warehouses, not selling well. Therefore, we decided to focus on the research and obtaining the materials which are affordable in their price, but at the same time have a complex of properties that allow them to be comparable with very expensive similar materials. The main fields of application of these materials is analytical chemistry, the water purification, extraction of and disposal of valuable ionic components, and radionuclide absorption. So at the same time, we have a task to obtain a sorbent with hierarchical structure that would have certain properties that enable to use it in a wide range of applications and tasks. But on the other hand, that would be commercially feasible for production. The product of these studies was a combination of organic, commercially available resins and inorganic exchangers. Commercial resins are strong. They have certain absorption potential, but they are chemically unstable. And they don't always are not always good in one-phase purification, which is complex to achieve. It's possible to compensate it with inorganic exchangers. And connecting the two materials into one, we can obtain nano-sized material of an orderly structure, which is better in the property than the analogies. The analogies, as a support base, we selected the resin which is used to soften the water. So it's the cheapest material. After that modification, we obtained material which is highly selected. It's the main property of absorption materials. Compared to famous analogies, our material, when absorbed nickel ions, extracts to 99.9% of nickel ions. At the same time, the volume that is spent on desorption is much less than similar commercial analogies. And of course, it requires much less agents for degeneration. And the capacity, our material supersedes commercial similar materials. If we apply these materials in specific paramembrane processes, we can confirm a high stability of our materials in time and high efficiency of extraction of wanted components. This material, in all its physical chemical properties, surpasses the organic and inorganic components. One of such materials has a passport, which complies with commercial analogies. It can be easily compared. We have obtained patent rights for its production and synthesis. The regular publications prove that indeed it is a modern work, not some fiction. We have developed lab regulations, and we now proceed to technological testing of small batches of these materials. Now, a few words about competitors in Ukraine. Of the two available companies that are now producing absorption materials, Cherkasy nitrogen factory are increasing their capacity, whereas the public enterprise Smolly are only producing small batches if you place an order. So basically the market is vacant. Whereas those distributors that sell Western or Eastern analogies do not cover the whole scope of problems for which there's a demand in the market. We see our niche on the market in absorption of radionuclides, radiological control, water purification. It can be agriculture or construction. We'll be able to present commercial batches that will attract investments for the project in order to expand the product line, and these are some of our contract information. Okay, how did you implement zirconium phosphide in the matrix? Okay, this is a know-how. I'm not telling. No more questions? Okay, thank you again.